Today we're going to look at operations of functions. It's a pretty basic section. The notation can throw you off a little bit. So let's talk about the notation. We're using function notation. Notice I've defined three functions here, f of x, g of x, and h of x. And we're basically going to do basic operations that you've been used to for a long time. Adding, subtracting, multiplying, and dividing. First example we'll look at is f plus h of x. Now here in the beginning, they will tell you exactly which two functions you're adding. So we've indicated that over here. Here's our two functions. And next thing we're going to do is look at combining like terms. So pretty straightforward, as you can see. You basically take your x terms in this case, add them up to get 4x. Then you have 4 minus 1, which is going to be plus 3. So your final function for f plus h of x is 4x plus 3. Next, look at subtracting functions. I have another example here for you. This time we're going to do f minus h of x. And I chose this one because h of x has a minus 1 over here. And that's a little tricky, so you got to be careful with that. So we're going to actually use parentheses for this, just to keep everything straight. So if that works for you, we'll go ahead and get started. One thing that sometimes students like to do is change their subtraction to addition. So if you change it to addition, just remember you have to change the sign of everything to the right. So if you prefer, you can go ahead and think about just this as an addition problem. And now it's a little easier to see that f minus h is 2x plus 5. We're going to take the 3x and we're adding negative 1x to give us 2x. We're taking the 4 and we're adding 1 to get a 5. Okay, our next task is to look at multiplying functions. I have the answer down here for us where we're going eventually. We're going to use the same functions we've been using. This time we're going to choose f dot g. So notice this closed dot does mean multiplication. And this is in contrast to our composition of functions, which we will indicate with an open dot. So when you see the closed dot, you want to think about multiplication. When you see open dot, composition of functions. Okay, now in this case we have what we call two binomials, or we have a monomial and a binomial, and we're going to multiply them together. So basically you're doing distributive property, 3x times 2x, and we're going to do 4 times 2x. And we get 6x squared plus 8x is equal to f dot g, or f times g. Now I have another multiplying function example for you, just to remind you how to multiply two binomials. So this time we're doing f dot h. And notice we have what we call two binomials, 2 terms there, 2 terms there. And if you remember from previous experience, maybe we're going to use this generic rectangle down here at the bottom. We're going to put one binomial on one side, and on the other side, we'll put the other. And to get the boxes, what we do is we multiply parts. So our first box comes from 3x times x, which is 3x squared. Our second box is going to be 4 times x. And then the last two boxes, again, we're going to multiply. So we're doing 4 times negative 1 to get the negative 4. And then 3x times negative 1 to get negative 3x. So our final answer here, if we combine like terms, and what I mean by like terms, sometimes we'll have some like terms here. When I combine those two together, I get x. So f dot h, or f times h, is 3x squared plus x minus 4. Last example we're going to look at is dividing functions. So you might be given the problem f divided by h. So you take the rule for f, you put it in the numerator. You take the rule for h, you put it in the denominator. And at this point we can't simplify. It's very tempting. Students want to make this 2x because they're doing 3x divided by x. But we can't do it in this case because we have a plus and a minus. So that is not allowed. So make sure you're not trying to cancel out terms that can't be canceled. At this point, you will have directions normally to identify what the domain is. And in this case, for a rational function, we have a ratio. So we call it a rational function. Ratio, rational function. We have to worry about the denominator. You've been told for years and years, of course, as Evan has, you can't divide by 0. This is not allowed. So what we have to do is figure out what value of x will give us 0 in the denominator. Now this one's easy to test because you can mentally solve this one. If I put a 1 in my denominator, I get 1 minus 1, which is going to be 0. Remember, we said we can't do that. So our domain, we could just list here as our domain is all real numbers Or we can say x is greater than negative infinity, less than positive infinity, and we're going to exclude x cannot equal 1. And that's our domain. So that sums up operations with functions. Hope that helped.